Hello, I'm Verdi Augusto, and this is the Schumann Resonance Harmonics channel on YouTube and Facebook. Thank you for being here. It is the 9th of May, 2021. It's about quarter of 9 p.m. Been kind of overcast today. Fairly a little bit chilly, but I don't know if it's unseasonably cold, but it definitely felt chilly. I didn't really go out today. It just saw it was kind of overcast. Happy Mother's Day for all of you who are mothers. My mom's gone, and I just, I want to wish all of you who are my regular, uh, subs and viewers who are mothers, thank you for being here. Appreciate all the support and the love that you've, and thank you everyone for being here. Thank you for the comments. Remember to like, share, comment, and subscribe. Show me some love. Let me know that, if you've gotten something out of the video, please let me know what you've gotten. And if you just want to say thank you for doing it, that's fine too. It wouldn't hurt to thumbs up the video, keep everything relevant. My videos are non-monetized, so I don't get anything from doing the videos. And when the videos are non-monetized, they don't go up high in the ratings. So basically, the subscribers I have all been mouth to mouth. Basically, is from you sharing my videos and all of that. So I want to thank you for what you've done and for helping me in this. I don't get any money, but I don't really have much else going on other than this. And this is basically what I don't know if I could say makes me happy. But I love learning about the Schumann resonances. I love just learning about that. Talking about it, getting other people to understand, a little different matter. That is what it is. But when people finally do get it and they they latch onto what's really happening there, that makes it worthwhile. Me just doing this, putting the videos out, like that's not really, you know, that is not its own reward. Again, I'm not getting money out of this. The only thing I get back from this is people who share what they've gotten, if anything at all. So please, that's why I like to hear the comments. It's nice to hear, hey, you're a great guy and all that, but it's not a lot of fun to do this without having people on the other side letting me know what they've gotten out of it. So, on that cheery note, this is all right. So this comes as a comment Facebook group. This is the coming a comment coming from Schumann Resonance Facebook group. That's one of the two that I admin. I'm not the founder of that group, but I'm the admin. Basically because I know the most about the subject and I've been around the longest and I worked through it as a group member, then a mod, and then an admin. So one of the comments was basically about Antarctica. All right. So they had asked about monitoring in Antarctica. Um, and I wanted to look for a spectrogram so you could, compare the two. But I think it's important to remember in the first place that when the scientists, technicians, the engineers, the scientists, uh, professors, whoever it is that makes these, the data comes out first and foremost as the line graph. Okay, that is what's called the dependencies. The antenna makers, the antenna operators may not have a spectrogram. That's an additional, extra component at the end of the chain. After it's been filtered, the signal has been amplified, everything has been do-si-doed, and the I's dotted and the T's crossed. Then do you get a spectrogram. But inherent and latent, innate within the recording means of the data for the Schumann resonance antennas, it's a line graph. What's a line graph? the dependency, this right here, okay? This right here is the dependency, and this right here is the line graph. See, they're showing you this peak frequency, intensity, that's the amplitude, X-ray. They're giving you an X-ray flux, and then numbers of flashes. Okay, so if you had a spectrogram based on those four panels right there, those four dependencies, your spectrogram would look significantly different from what you see on Tomsk, because in this case, you're measuring number of flashes. That is not a dependency that's found on Tomsk. You got to realize that. There is not necessarily a standardized way of publishing the results that equal a spectrogram. Right? A lot of people call the spectrogram the Schumann, and that's the problem with this. That's entirely what the problem with calling the spectrogram the Schumann is, that one gets into the thinking pattern, the rut, that the spectrogram is plotted directly from the atmosphere. All right? A lot of people are calling the spectrogram the Schumann, and I'm going to do a video on this just for this alone. But I want to kind of encapsulate the problem with calling it the Schumann is that when people think of the Schumann resonances, they automatically think of the spectrogram, which is end of the line. It's the caboose. It's not a one-for-one plotting of the atmosphere itself. That's why a lot of people are really mistaken when they go to the spectrogram, calling it the Schumann, thinking it's a one-to-one plotting, it's a direct correlation between the atmosphere and what's going on, and that's their interface between the invisible world. And that Schumann could be anything. It could be a data breach, it could be censored data, it could be a gamma burst, it could be an X-ray, it could be elves farting, a unicorn peeing on the machine. Oh, it's golden stream. Oh, will that show up on the Schumann resonance? If a unicorn goes walking through the room with with the antenna, will that show up on the Schumann resonance? Okay, so onward and upward on the cheery note. That's why it's super important to understand that the spectrogram is a composite or a compilation of the dependencies, which are the dependencies is the direct raw data coming from the filtering and the amplification system of the whole stream there, the whole data stream from when it's happening, it's getting picked up, filtered, amplified, front end unit, conditioned, then goes out to the line graph, so you have a good representation, a solid representation of what's actually happening on the ground, as it were, or in the air. Those line graphs give you the exact one-to-one analog of the signal that's happening. That's why the spectrogram is the spectrogram. It is the composite plotting of the dependencies of whatever you got, frequency, amplitude. The spectrograms are based on the dependencies. And just looking at a spectrogram, unless you know what is in that, you're fucked. It becomes a belief. It becomes a religion, right? You got this symbol like Jesus on the cross. The spectrogram, the Schumann is basically Professor Schumann on a cross with all the fun colors there that you could make up to be anything that you want. Oh, Professor Schumann says today that I should feel ringing in my ears. Oh, Professor Schumann today says I should be perking up and full of... Why aren't I full of energy? All right, so these are what you get with the Schumann as your leading icon in the march. Okay, that's the difference between the Schumann and the spectrogram. The Schumann is the vestigial remains, like Jesus on the cross, the vestigial remains of the personality in your religion, the personality head in your religion. Okay? They did that with Christ. They did that with the Hare Krishnas. Humans do that with personalities. They turn them into gods, into deities. So here, in the case of this, that's why the Schumann is so special, so different, because you have deified the poor professor, who's probably turning in his grave, flip, 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 like a dynamo. He's probably got a power field around Professor Schumann in his grave has been flipping so many times that there's probably a power, grid around his his grave that we can tap into, and that in itself, the Professor Schumann's grave is itself a power source. Did you know that? Well, now you do. Okay, if this comes as news to you, I hope it's good news. All right, so we're at our 10-minute mark. Okay, 10:40. All right, aye, 10:40. So this is the comes as, like I said, as a result of the conversation I had in the comments on the Facebook group about Antarctica, and so I just was like, I know I get something on there somewhere. I can find something. So this was something, I don't think I've seen this before. I've come across data on Antarctica, but I think this is the first time I've actually seen this particular one. All right, so the authors are Koloskov, Budanov, and Yampolski. I don't think I'm pronouncing any of those names correctly, but there it is. All right, so this is on the website. The first opening thing was a picture from the website. This right here is from the PDF. And I think the link, you can go to the website and get the PDF. You can click it from there. The description will be, that link will be in the description, I hope. I'm intending it to be. So these guys are all Ukrainian. And there is they're measuring the Antarctic up there. Uh, and they're people wonder what, again, this, like I said, this starts out, what would the difference in the spectrogram look like between there and there? And the answer to that is you don't know, because Tomsk is not doing it. Whoever else was doing it was going to give you a different spectrogram. You see the one at Kumiania, you see the one in Etna, roughly similar. And I pointed out the color codes. The I think it was the second before the video before that last one I did. I pointed out the color codes and the DM, the dB meter, what I'm calling a view meter, but the decibel meter. Okay, different color codes going from dark blue to red, where it goes in the yellow in the middle at a certain point, or white in the middle there at a certain point. Just because it's going the colors, it doesn't necessarily mean that a color on one spectrogram is going to be the same as a color on another spectrogram. You have to look at, I just whacked my microphone, thank you. You have to look at the data, the dependency data, to know what it is you're looking at. What is this? A composite means a bringing together of a bunch of different sources. So the composite depends on amplitude, quality, and frequency in the case of Tomsk. But other places have other dependencies, and you saw down here, if they're going to give you a spectro of these four dependencies right here, it's going to look significantly different than you would get at Tomsk. All right. So I'm at the risk of, I'm repeating myself. You need to hear it again. I'm here to say, I'm not repeating myself word for word. This is a little different, explanation of what's going on, why it's important. It's just freaking important for you to get the data behind the spectrogram so you know what the fuck you're looking at. It's not difficult to understand that. What are you looking at? What is the data, the actual data behind the scaled view of the spectrogram? All right, so this is long-term monitoring Schumann resonance signals from Antarctica. The abstract in this paper. Let me know. Abstract. In this paper, long-term data sets of the Schumann resonance SR signals observed at the Ukrainian Antarctic Station, UAS, are analyzed. It has been found that the long-time trends of the peak frequencies and intensity of the fundamental Schumann resonance mode, that's 7.8, fundamental Schumann resonance mode is 7.8, correlate with 11-year solar cycle. No trend of yearly averaged numbers of lightning flashes is observed in LIS satellite data for the same period. It is suggested that the long-term variations of the intensity and frequency of the SR peaks were caused by changes in the ionosphere controlled by solar activity. Okay, read that again. It is suggested that the long-term variations of the intensity and frequency of the Schumann resonance peaks were caused by changes in the atmosphere controlled by solar activity. As is known, let me pause this so I can have a drink and clear my throat. As is known, Schumann resonances, SR, are stimulated by global lightning activity. Lightning discharges excite resonance signals in the cavity formed by the Earth's surface and the lower boundary of the ionosphere. Reference 102. As was shown in the paper, reference 3, long-term records of the intensity of the fundamental harmonic of Schumann resonance signals can be used to monitor trends in the tropical surface air temperature. However, the mechanism of the lightning activity global temperature coupling has not been well described theoretically. Long-term, high-accuracy observations of Schumann resonance signals can be helpful in experimental study of this effect. To the best author's knowledge, there are only few papers, references 4 and 5, reporting on records of the kind. An important issue while processing Schumann resonance data is to isolate signals produced by the lightning activity, the global lightning activity from interference radiation produced by local lightning discharges and technogenic sources, which can significantly deteriorate the quality of the data. As is suggested in paper, reference 6, the best location for a Schumann observatory is the polar region, owing to the absence of local lightning and technogenic activity. This is a reason why monitoring of Schumann fields has been initiated at the Ukrainian Antarctic Station, UAS. It should be noted that an additional advantage of the UAS is its location on the same arc of a great circle with American and Asian centers of the global lightning map. The global lightning activity. Such geometry makes it possible to separate contribution of different centers of the global lightning activity, 7 and 8 references, from the total Schumann resonance signal. In the present paper, Schumann data recorded at the UAS from 2000 through 2012 are analyzed. It has been found that long-term trends in intensity and peak frequencies of the fundamental Schumann mode correlate with the 11-year cycle of the solar activity. The data are compared with the seasonally averaged numbers of flashes obtained from the Lightning Image Sensor, LIS, satellite records. As a result, it has been found that the numbers of lightning flashes demonstrate practically no variability from one year to another. This suggests that the long-time variations of Schumann parameters detected at UAS were caused changes in the lower ionosphere controlled by the solar activity rather than by variability of the parameters of the world lightning centers. All right, so that's pretty significant to understand. What he's talking about is, I think that's fairly readily evident, but that's just me looking at it. Maybe it's not so obvious. There's a lot of words there. Um, basically, they're looking at they're monitoring in Antarctica which is a great location to monitor Schumann resonances because they're clear of technogenic, that means man-made influences, like the power lines in Kumiani. You see the 50 hertz line that goes across it. In a lot of places you see a 50 hertz line. Some places you see a 25 hertz line, maybe from the electric trains. I don't know. There's one at 17. I can explain to you what's at 17 hertz. I can explain what's at 25 hertz. Right. So I can explain to you how you get these lines that go across. So what they're talking about is and the frequency, dedicated frequency lines, I call those. Um, so what they're talking about here is that in the polar environment, it's a good place because there's not influence from, you know, things like that, and there's not much inherent lightning, if any, in Antarctica. It would be odd to get lightning up there. So therefore, it's perfect because it's far enough away from its own lightning sources, and that's something that you can't guarantee with Tomsk and Kumiania or any of these other places because they are closer to where the lightning does happen. Okay, and I'm not going to go into more specifics on lightning, just simply that, there are areas of the world that lightning is concentrated in. These are around the equator. It's where there's hot, heat, blah, blah, blah. There's a lot of stuff that goes into it. So they're at a place that they can monitor the resonances without this kind of interference. So what they're essentially looking at over the course of the 20 years that they've done this is the 11 years sunspot cycle, solar activity. And so following, you look at the charts. And so following the peaks, they're looking at the peaks, the peak, the peak, the peak, the peak. So based on the peak readings, they're using that as the primary means of judging the effect of the solar cycle on the ionosphere. What they're also telling you is that they looked into the comparison of the lightning discharges based on the satellite data. And based on the satellite data, the data source they're going by, there hasn't been a diurnal variation in lightning, which is interesting to note. So a lack of diurnal variation in the lightning would lead them to the conclusion, reasonably speaking, after 20 years of doing this, that it's the ionosphere interacting with the sunspot cycle that is affecting the greatest change in the readings of the Schumann resonance graphs. Okay, measuring and data processing techniques. Two orthogonal horizontal components of the magnetic field oriented in south-north and east-west directions of the geographic coordinate system have been monitored at UAS, and they give you the coordinates there, 65 by 15 and then 64 by 16, since March 2002. To that end, an induction coil magnetometer, LEMI 112, was used until 2011, which recorded Schumann resonance signals in the frequency band 0.1 to 300 hertz. In April 2011, the hardware was changed to a LEMI 419 ANT with larger dynamic range and wider operation frequency band, 0.001 hertz to 80 hertz. Wow. The devices have been both manufactured by the LVIV Center of the Institute of Space Research, and there's a link to that in the Schumann Resonance website article that I did here. The instruments are capable of recording the absolute values of the magnetic field in a digital form and are equipped with GPS system for synchronizing with the universal time UT. The spectral and polarization techniques, reference 8, were used in data processing. At the first stage, the power and cross spectra of the signals averaged for each 600 seconds interval are calculated. These data are used to determine the Stokes parameters and compute the intensities, degree of polarization, ellipticity, and position angle for the first three modes of the Schumann resonances. The values of peak frequencies for both polarization channels are calculated as well. Then, using what is that word? Asymptotic? Okay, that's a new one for me. Asymptotic. I couldn't tell you anything about that. Developed by the author of the paper. Well, we can look there in reference 7 and see what it says. The activities of the world lightning centers are estimated. The activity of the African, A1, and the sum activity of the Asian and American, which are A2 plus A3, centers are calculated using the technique described in paper 8. In the present study, we analyze monthly averaged parameters of the fundamental Schumann resonance mode calculated for the period from March 2002 to December 2012. March 2002 to December 2012. All right. Okay. So what we're looking at, they're giving you the years here on the bottom, boop, 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 and this is the time in universal. So this is 6, 8, 10, 12, 14, 16, 22, 24. All right. So these are, what they're giving you is the first, the time is this is not time. These are the first modes, sorry. Times in maxima observed in the monthly observed activities of the world lightning centers calculated from the Schumann resonance data recorded at UAS, that's dashed lines, and estimated from seasonal distributions of lightning flashes obtained from LIS data solid lines. Oh, I see. The green, blue, and red lines correspond to the Asian, African, and American centers, respectively. All right. So the green is Asian, the blue is African, and the red is American. All right. Well, this is interesting. All right. So there's a lot more to this that I'm almost at the 30-minute mark, and I want to keep these videos around 30 minutes, these short kind of videos. And there's a lot more to go into with this, and I really would like to kind of show you more of this, but it's kind of a little bit beyond what I think we're looking to go at this time. The 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 main point of this, the main takeaway, is that the Schumann resonances change over the course of time. This is the sunspot diurnal variations. The phrase diurnal variation not only includes daytime to nighttime reading, but it also includes from the beginning of the month to the end of the month. It also includes over the course of time, over the course of years, over the course of the sunspot cycle. So people that are new into this are looking, oh my God, there's peaks. And it's like, well, yeah, at certain times of the year, you get more peaks. At certain times of solar activity, like when we're getting sunspot activity, yeah, that has an effect. The sunspots themselves have an effect on the Schumann resonances. Just understand that. Just dig on what I'm saying. Doesn't have to do anything. Not a solar flare, not a CME, none of that. The presence of a sunspot itself changes the Schumann resonance. So when Mr. MBB sees those peaks and he says, for I don't know why, it's because he hasn't read the data. When everyone else says, oh, I don't know why. Wow, no, it's not solar activity. It's not solar blasting. It's not CME. No, it is simply the presence of a sunspot. You get these 110 amplitude days simply for the presence of a sunspot. That's it. That's all. That's it. That's it. That's it. That's the end of the video. That's everything you need to know right there. If you can't find anything else, sunspot in the area, sunspot in the neighborhood, there you go. That's it. That's it. That's it. It's that simple. You get a 100, you get an 88 day like we had 3 days ago. You get a 77 day like we had. You get a 110 day like we had the other day. Sunspot. Depending on what the sunspot's doing, there you go. Okay. But remember, it is always the sunspot's effect on the ionosphere, or it is the sun's effect on the ionosphere, or it is the gamma ray burst effect on the ionosphere, or it is an X-ray flare burst on the ionosphere. But at all points, when we're talking about the Schumann resonances, you need to understand it is the whatever, insert your whatever theory here, effect on the ionosphere. If the ionosphere is not present, there is no Schumann resonance. So depending on what the conditions of the ionosphere is largely the condition of the Schumann resonances. They are a product of the atmosphere bouncing off of the ionosphere and then coming back down to us in whatever form it does. But if the ionosphere comes down closer to us, generally speaking, resonances tend to rise up. So that's kind of the rule of thumb on that. All right. So okay. So thank y'all for being here. On that cheery note, I think we've kind of leave you with the. There we go. So I'll leave you with the line graphs as the outro, so you have a chance to. Well, that might make a good thumbnail. When I do these videos, I don't always know what the thumbnail is, at the front, and sometimes in the course of doing them, I say, "Oh, like, yeah, I see the picture. Like that might be a good thumbnail." So I don't know. Anyway, all right. On that cheery note, it's time to go. I got to post this. Thank y'all for being here. I don't know. Maybe I'll post this as a premiere. I don't know. It's 30 minutes. So, I've seen people do premieres for like a 15-minute video. I'm like, okay, yeah, whatever. All right. So mine's 33 minutes. All right. Or will be. All right. Once again, thank you all for being here. I appreciate the love, the comments, and the support from everyone. Share the video. Let everyone know, this is what's going on with the Schumann resonances. I don't do this every day because I'm not. The job here isn't to, give you the everyday reading of the Schumann resonances. My job here is to explain in depth and in detail how this works and how you get the image and what that means. It's not for me to assign some kind of a pain or an ache to you. Right? That probably isn't what the Schumann resonances are actually doing. You probably have some other shit in your life you got to clear up first. And that's generally speaking what I've been finding, that the people with the dirtiest lives are the ones complaining the loudest about what the Schumann resonances are doing. It's just an observation, just my humble opinion. So, all right. So, on that absolutely cheery note, thank y'all for being here. I appreciate the love and support.